Hi guys, welcome to another episode of Learn Technology in 5 Minutes by Makerdemy. This is Naveen and part of the instructor team at Makerdemy. In this episode, you learn about the Keep Alive implementation in MQTT and why it is important. As the name suggests, the Keep Alive feature is literally used to keep a network connection alive. This term is not limited to MQTT but also used in many other protocols. In general, Keep Alive ensures that the connection between a server and a client is still open and both are aware of being connected. This reduces network congestion and latency by ensuring that a single connection is used per client. This is highly desirable, especially in the case of machine-to-machine communications where the nodes have very limited resources. This is why inventors of MQTT have added the Keep Alive feature to it. If you have been following our MQTT series, you'd already know that MQTT is based on TCP/IP model, which ensures that packets are transferred reliably, orderly, and in error-checked manner. In fact, the transport layer in MQTT uses Transmission Control Protocol with its own Keep Alive feature. Then you might ask, what is the need for an extra Keep Alive implementation on the application layer? Wouldn't it add an additional overhead? In real-life applications, especially in the case of IoT devices, with so many limitations on the network, the transfer between communicating parties can get out of sync due to clients crashing, unreliable network, or other errors even with the TCP Keep Alive implementation. Moreover, due to client decoupling nature of MQTT, if a connection is half open, the side that is still connected keeps trying to send messages and waits for acknowledgements. If you want a more detailed answer to this, you can check out this forum thread, where the inventor of MQTT protocol, Andy Stanford Clark, has clarified the doubt. I have provided the link in the description of this video. Now let's look at how Keep Alive works in MQTT. When the client establishes a connection to the broker, the client communicates a Keep Alive time interval in seconds to the broker. This interval defines the maximum length of time that the broker and client may not communicate with each other. As long as messages are exchanged within the Keep Alive interval, there is no need to send an extra message to establish whether the connection is still open. If the client does not send a message during the Keep Alive period, it must send a ping request packet to the broker to confirm that it is available and to make sure that the broker is also still available. The broker will respond back with a ping response packet to the client and the connection is still maintained. On receiving the ping response, the Keep Alive timer is reset and the cycle continues. The broker must disconnect a client that does not send a message or a ping request packet in 1.5 times the Keep Alive interval. Likewise, the client is expected to close the connection if it does not receive a ping response packet from the broker. If the client has set a last will and testament message, during this disconnect, the LWT message will be forwarded to all subscribed clients. It is also to be noted that the maximum Keep Alive interval allowed in MQTT is 18 hours, 12 minutes and 15 seconds. Can you research why the Keep Alive is limited to this time interval? Post your answer in the comments below. In this video, we have learned what is Keep Alive in MQTT and why it is important. That is all folks. If you like this video, smash the subscribe button and ring the bell to be updated about our future video releases.